Hello. So one more hypothesis test here, and let's just jump right in. So here's our situation. We've got a marketing belief that 92% of adults in the US own a cell phone, but then a cell phone manufacturer believes for some reason that this number is actually lower. So they survey 200 adults, and 178 of those 200 report having cell phones. And we want to test whether this supports their claim that there is actually a lower proportion or not. And we're going to test it with a 5% level of significance. So in this problem, well, let's start with our H naught and our A. So H naught is that 92% of adults in the United States own a cell phone. This is a proportion, right? That's what a proportion is. The proportion out of the group that has it, right? We usually give those as fractions, or it can be as a fraction or a decimal or a percentage, right? Right, if you said half of all Americans, then that would be the proportion. But in any event, what we're saying here is that the proportion is 0.92, okay? Right. That's what we're going to assume to be true. That's what is the accepted belief that we are suspicious about. What we believe, or us acting as this cell phone manufacturer believes, is that the proportion is actually lower than this. Okay, so those are our two hypotheses. Okay, and we have an alpha of 0.05. So I think it's clear what proportion or what test score we should use, or test statistic we should use. I just said it again, proportion, right? We're talking about proportions. We want to know if this proportion is true. We test with the proportion. So we compute our test statistic as p hat minus p over the square root of p times 1 minus p divided by n. So I'll just remind everybody what these things are. P is, of course, the proportion, and in this case, it's the proportion in our null hypothesis, the one that we're assuming is true. P hat is the proportion, is the test proportion. We actually don't know that yet, though we're given enough information to find it. P hat is going to be the number in the sample with the characteristic divided by the number in the sample. So in this case, that is this 178 out of 200. So 178 of the people sampled have cell phones out of 200, which gives us a sample proportion of 0.89. Okay, so that's what goes in here. The proportion we're assuming is true is 0.92. So then we get the square root. 0.92 times 1 minus 0.92 divided by our sample size of 200. And I get this to be negative 1.56. Okay, so that is my test statistic. So in the last couple of videos, I checked the test statistic by comparing it to a critical value. Let's do something different. In this case, let's compute what's sometimes called the p-value. This is the probability of getting this z-score or more extreme. So in this case, it's getting a z-score of negative 1.56 or below a negative 1.56. And so this we can just compute on a normal distribution calculator. I already punched that in and get 0.0594. Okay. This means, notice, this is greater than alpha. In other words, the p-value is greater than alpha. And in that case, what we're saying is getting a z-score this low is still pretty rare, but it's not rare enough. Our cutoff point is alpha. That's the rare where we say that's the amount of rareness that we say becomes too rare to accept the null hypothesis. Well, we're still pretty rare, but we're not that rare, right? We're more likely than 5%, which was our cutoff point. And so we say we fail to reject H naught with 5% level of significance. Okay, and that's it. So I think we've covered most of the kinds of situations. We've seen one-tailed. This is another one-tailed test because we just were looking below, right? We took, we found our p-value was the area below, and we found that to be below the z-score associated to the alpha value. We looked at two-tailed tests. We did it for all three types here. Okay, so that is it for our hypothesis test examples. There's a couple other ideas I'll talk about in some other videos, these error types and so forth. But these are the three big things we want to do with them. Okay, that is it for this one. Thanks everybody, and I will see you next time.